Your phone knows exactly where you are. Not just the city. Not just the street. It can often tell which side of the road you're standing on. We use that little blue dot every day, but almost nobody stops to ask how it actually knows. It isn't using a camera. It isn't pointing a laser into space. And no satellite is looking down to find your phone. In fact, GPS satellites don't even know you exist. That sounds impossible, because it is completely different from how most people imagine GPS works. The truth is even stranger. GPS isn't really solving a location problem. It's solving a timing problem. Everything depends on measuring time with astonishing precision. And once you understand how GPS measures time, you'll discover something even more surprising. Your phone quietly proves one of the strangest ideas in modern physics every single second. Every GPS satellite is constantly broadcasting just two pieces of information: where it is, and the exact time the signal left the satellite. That's it. No maps. No directions. No tracking. Just a position and a timestamp, repeated over and over, every second of every day. Those signals travel at the fastest speed the universe allows. The speed of light. Nearly 300,000 kilometers every second. By the time one reaches your phone, only a tiny fraction of a second has passed. But that tiny delay contains everything your phone needs. Your phone compares the time the signal was sent with the time it arrived. Multiply that travel time by the speed of light. And one simple number appears. Distance. Your phone now knows exactly how far away that satellite is. Not because anyone measured it directly, but because time became distance. But knowing your distance from one satellite isn't enough. Imagine someone tells you you're exactly 10 kilometers from a lighthouse. That narrows your location, but only to a huge circle. Add a second satellite, and the possibilities shrink. Add a third, and only one location makes sense. This process is called trilateration. GPS doesn't measure angles. It measures distances. There's one final problem. Your phone doesn't contain an atomic clock. Its internal clock drifts by tiny amounts. Normally, that wouldn't matter. For GPS, it matters enormously. An error of just 1/1,000,000 of a second would place you hundreds of meters from your real location. So your phone listens to one more satellite. Not to find where it is, but to correct its own clock. Now everything fits. The satellites know where they are. Your phone measures how long every signal took to arrive. Time becomes distance. Distance becomes location. It seems like a perfect system. Except for one impossible problem. The clocks in space don't tick at the same speed as the clocks on Earth. There's just one problem. Everything you've seen depends on every clock measuring time at exactly the same rate. That sounds reasonable. Build two perfect clocks. Set them to the same time. And they should stay synchronized forever. Except they don't. GPS satellites travel at nearly 14,000 kilometers per hour. 20,000 kilometers above Earth. Out there, gravity is weaker. According to Einstein, both speed and gravity change the rate at which time passes. That means satellite clocks don't tick at exactly the same speed as clocks on Earth. The difference is tiny. Satellite clocks gain about 38 microseconds every day. That's less than the blink of an eye. But GPS measures time so precisely that even this microscopic error becomes enormous. Ignore it, and your location would drift by kilometers every day. So before a GPS satellite is ever launched, engineers deliberately adjust its clock. Not because it's broken, because they already know space changes time. Every time you unlock your phone, GPS quietly confirms one of Einstein's greatest discoveries. Not in a laboratory, but in your pocket. By now, it's easy to think GPS is just a navigation system. It isn't. Navigation is only one thing it does. Every second, GPS provides an incredibly precise reference for time, and countless technologies quietly depend on it. Aircraft navigate with it. Ships cross oceans with it. Farmers plant crops with centimeter-level precision. Banks use precise timing to help synchronize financial transactions. Power grids. Emergency services. Telecommunications. Every day, millions of systems rely on the same invisible clock. The remarkable thing about GPS isn't that it tells you where you are. It's that most people never notice it's there at all. Every time you unlock your phone, follow a map, or simply check the time, you're relying on thousands of engineers, dozens of satellites, atomic clocks, the speed of light, and an idea that once seemed impossible. Sometimes the greatest technologies aren't the ones that demand attention. They're the ones that quietly become part of everyday life. This is Crimson Focus. Because understanding the future begins with understanding the hidden systems that shape our world.